This thing is... Alright, this thing should be going. Alright, so, sorry I couldn't be here today. I'm sick, unfortunately. So I'm going to send this video up on Schoology, and hopefully you can watch it and try to keep along. I'm sorry if it's a little bit harder to understand or view because you won't be able to ask questions back, but hopefully everything keeps going the way it should. Alright, so you have this warm-up. Thinking back to what we did on Tuesday, we talked about finding perimeter of shapes and finding perimeter of these diagonal lines using either our Pythagorean theorem or our distance formula. And just for those who want a quick refresher on what those might look like, that was our, let's see if I can do this on here, a squared. That's not going to work out. I'm not going to do that. That was our a squared plus b squared equals c squared, or our square root of the x2 minus x1 squared plus y2 minus y1 squared. Those were our distance formulas that we talked about the other day. So take a moment, see if you can find the perimeter of this triangle. I will try to get the distance formula up here as soon as it starts responding to me, and then I will give that to you. So d equals, and then we need to do the square root of it's x2 minus x1, and then that whole thing squared, so raised to the power 2, plus y1 minus y, or y2 minus y1 squared. And all of that was under your square root if you drew your line over. And so you take your coordinates, and you guys know what you're doing. I'm sorry if this is a little chaotic. I have to rush this a little bit. But see if you can find the perimeter of this triangle from that warm-up. See if you can find the perimeter of this triangle either using your Pythagorean theorem or the distance formula like we did. And once you get that, then, or pause the video until you get that. And once you get that, you can move on, and we'll talk about what we need to do next. Alright, depending on which method you did, you should get 8 for your long side because we can count that 1, 8.06 for both of your other sides because they have the same measurements, and then 24.12 is your total all together. Very good. Alright, so we're talking about coordinate geometry. So coordinate geometry involves using using your coordinate plane to do geometry. So yesterday or Tuesday we talked about perimeter. Today we're going to talk about area. So that means area of different shapes. So we have to remember what some of our area formulas were. For example, area of a rectangle. So some of these we should have talked about in 8th grade or 7th grade. So some of them might seem familiar to you. But hopefully we'll do a quick review over them today. Give me one moment. Alright, so area of a rectangle. Area is equal to base times height. I'll put these in capital letters. Base being one side of your rectangle, height being the other side. That's pretty simple, pretty easy. You measure both your sides, multiply by each other. Square. The area of a square is equal to base squared or height squared. Because we know all four sides of the square need to be the same, you know your base and your height are going to be the same number, so base times base is just base squared, or height times height is just height squared. So one of those sides squared, that's all you need, and that gives you your area of a square. Now if we think about a triangle is half of a rectangle. So all we have to do is take the area of a rectangle and cut it in half. So area of a triangle is 1/2 base times height. And that is our rectangle. Thing about this, we have to know that the height is always going to be perpendicular to your triangle. So if we created a triangle, our height needs to be perpendicular to that. So it always needs to make a right angle with the base. So it can't just be any random line created from your triangle. It has to be perpendicular to the base. So it needs to create that right angle in that bottom there for your height. And we'll talk about why that gets tricky later on. Trapezoid. Trapezoid, if we think about what a trapezoid has two parallel sides. So we have two parallel sides, and this is very similar to a triangle and a rectangle in you might not remember this one, but this is 1/2 base 1 plus base 2. Base 1 and base 2, these are your parallel sides. So base 1 would be down here, this bottom length. Base 2 would be up here, this top length. So you'll multiply both those together, or you'll add both those together, base 1 and base 2, and then you'll multiply those by your height as well, just like always. So let me stretch this out. Once again, the height needs to be perpendicular to your base of your triangle, or base of your trapezoid. So this could be our height, for example, because that makes a perpendicular line. And so the issue is just having to measure those. So there's a little right triangle in there. Or right angle, sorry, not right triangle. Whatever. So base 1 plus base 2, add those together, multiply that by your height, and cut it in half, and that is your height of your trapezoid. So these are our different area formulas. You want to write these down. We'll be using these in the future with what we talked about on Tuesday. Alright, so the area of each of these, or find the area of each of these polygons. Alright, so most of these are pretty simple. It's just using our height formula. So looking at this right triangle, we need to find, we know our area of our right triangle is 1/2 our base times our height. So we need to figure out what these values are. So we have 1, 2, 3, 4. That's my height of my triangle. I know because this is vertical and this is horizontal that they're perpendicular to each other. So this would be my base. So 1, 2, 3, 4, 5, 6, 7. So I need to do 1/2. Sorry about my handwriting with this mouse. 1/2 base of 7 times my height of 4, and you can plug that whole thing into your calculator, and that will give you, let's see, it should be 28, I think. 7 times 4 times 1/2 gives you 14, I'm sorry. Yeah, 4 times 7 is 28. Alright, so 14 would be your area of a rectangle. So that's pretty easy. We can just count those sides, and that works for us. With this one, it's a little bit harder for this rectangle. We know we need to find the base, and we know we need to find the height of our rectangle. But the thing is, once again, these are our slanted lines. So we're going to have to find the length of both of these using either our Pythagorean theorem, like we talked about on Tuesday, or our distance formula. Once again, either method works. It's just your preference. So take a moment, see if you can find your base and your height for both of these. Then multiply them together and find the area of that shape. Alright, so if you find your base and your height, you should get 5 for your base and 10 for your height. We know because it's a rectangle, these are right angles, so we know that's our base and our height. And then from there, we can do 5 times 10 gives you 50 for your base and your height and your area of your rectangle. It's very good. So with some of these shapes, you might have to do a little bit more by having to find those lengths using your perimeter or using your distance formula or your Pythagorean theorem like we talked about the other day. I'm sorry. Alright, so we can keep going. How to find the height of a shape. I'm sorry if I'm going really quick on this. If you need to watch the video a couple times or go back and review over some things, or go back and review some of the, or listen to it twice just to sort of catch it in. I'm sorry, once again, I'm just all over the place. We'll talk about this more tomorrow when I come back. Find the height of the shape. Okay, so we know we have a base of a triangle. Once again, the base can be any side of your triangle. It's just you need your height to be perpendicular to that base. So I'm going to designate this as my base. It doesn't matter. I could do any of the other sides, but I think this just seems easier to use that side. But it doesn't matter which side is your base. You can use your base from any side of your triangle. It's just finding the height needs to be perpendicular to that base. So we need to find the height. So the thing is, the height needs to be perpendicular. So I need a perpendicular line to this base. Now, if we remember the word perpendicular, what requires a line to be perpendicular to each other, it means they need opposite slopes, opposite reciprocal slopes. So that means we need to figure out what is the slope of my base right here. And so I just need to pick 2 points that my that my line passes through to find the slope. So that's our like rise over a run. And luckily this line has a pretty easy slope. We go over 1 and up 1. So my rise is 1 and my run is 1. So 1 over 1 is my slope of my base. Now I just need to think what is going to be the opposite reciprocal slope of that. And I can do that pretty easily. If I flip 1 over 1, it's just still going to be 1 over 1, but I just need to make it an opposite. So now it's negative 1 over 1. So negative 1 over 1 will be the slope of my height of my triangle that I'm looking for. Now the thing is, where do I have to start with the height of my triangle? So the height of our triangle is always going to start from the opposite corner of your base, or the opposite angle of your base. So if this was our base, our opposite angle is up here. If this was our base on the top, our opposite angle is the bottom. If this was our base, our opposite angle is the west side. So I'm going to start from that point up there, and I'm going to just use the slope. So I need to go down 1 over 1, down 1 over 1, down 1 over 1. And you see how this goes. So I can just grit my line, and I'll make it green for us. Down 1 over 1. We keep going all the way until we hit right here. And now that I have this height drawn in, I know it's perpendicular because I use my perpendicular slopes. Now that I have this height drawn in, I can then find the length of this line using my distance formula, using my Pythagorean theorem. And now that once I get that, I would have my height and my base, so I can do 1/2 base times height to get the area of the shape. I know the question just says to find the height of the shape, but once we get the height of the shape and once we get this base length, then we can find the area. So sometimes, depending on how the triangle is oriented, we have to might do a little bit extra using that slope to find those, to create those perpendicular lines, to create that perpendicular height. So pause. So take a moment, see if you can find this base length using your Pythagorean theorem. See if you can find this height length and then multiply 1/2 base times height to see what that is. Alright, so we should have gotten our base to equal 9.89. For this side, our height is 11.31. Once again, using your Pythagorean theorem or your distance formula, either method works. 1/2 base times height, we multiply all those together, we get 55.93 should be your area of your triangle. So very good, very good. Alright, we're cutting close on time, Alright, find the height of the trapezoid and then find the area of it. Alright, so once again, very same idea from last time. Area of our trapezoid is 1/2 base 1 plus base 2 times our height. So it doesn't matter which side is base 1 or base 2. So we're going to say this is base 1, this is base 2. We're going to have to find the lengths of those. So find your lengths using your Pythagorean theorem or your distance formula. Next thing is, once again, you're going to have to find the height of the trapezoid. The height of the trapezoid, if we measure from one, we need to figure out what that perpendicular length is from one base. Now, because it's a trapezoid, we know both these sides are parallel to each other. So perpendicular to one of those bases will be perpendicular to both those bases because parallel lines have the same slope. So we need to figure out what that slope is of my parallel lines. So if I look, we're using my rise and my run from this point right here to this point over here. I'm going down 1 over 2. So negative 1, 2 is my perpendicular, or is my parallel line slope. So I just have to think, what is the perpendicular to that? Flip it upside down. And because this was a negative, I need to make it a positive. So negative 1 over 2 becomes 2 over 1. 2 over 1 is going to be my height, or my perpendicular height, or the slope of my height. So once again, it doesn't matter with a trapezoid because it's a full line. It doesn't matter where I put that height. I'm just going to put it right here at one of these points, and then I'm just going to use that slope. So up 2 over 1, up 2 over 1, so we get right here, and that is going to be my height. And once we put this height in here, then we'll be able to, sorry about that. So once we put that height in there, then we'll be able to find the length of that height using our Pythagorean theorem and our distance formula once again, just like what we did. So find the length of your base, find the length of your base 2, find the length of your height. Now that we have it created using our perpendicular lines, then you can do 1/2 base times, or base 1 plus base 2 times your height, and we can get the area of this whole shape once again. So take a moment, see if you can find that real quick. All right, oh no. Hopefully we were able to get that. Sorry, I can't remember what the answer is off the top of my head, but I need to keep moving because we're running out of time. So using a GPS, a farmer was measuring her rectangle field. She found that the coordinates of the corners of the field from her current location in miles are 7, 0, -6, -4, -2, -3, and 3, -12. What is the area in square miles? All right, so some things you might notice with this problem. We have a rectangular field. Sorry, just cut that out. So a rectangular field. We have the 4 corners. So what you'll need to do is you might have to, like what we did in the past, is you might have to create a little grid and place these points on this grid. So once again, it's just going to be a rough estimate, rough sketch, so you might not be perfect, but that's okay. We don't need perfect, we just need coordinates. And so you can place your points on here. You should get something that looks roughly like a rectangle, because we know it's a rectangular field. Because we're told it's rectangle, we know our area is going to be base times height. So figure out what your base is from two of your sides. Figure out what your height is from one of your sides, and then multiply those together to see if you can find the area of your field. Once again, I'm really sorry that this was super quick, super short. Work through these problems. If you need review, once again, review those areas. We're going to talk about this a lot more tomorrow. But if you need to, watch over this twice. You probably have enough time in class. Work on these problems, try to get them, figure out what some questions you have for me tomorrow, because I know I probably didn't answer any questions you probably have a ton of. Once again, I'm really sorry for being sick today. Just get this, watch this video, work on these problems, let me know for some questions, email me if you have anything else that you need.